Assalamu alaikum, viewers. Welcome back to the channel. Today, we're tackling a common problem: repairing a dead inverter AC outdoor PCB. We'll be going through the entire process, step by step, in both Urdu and Hindi, so everyone can understand. Imagine your inverter AC is completely unresponsive. No display, no fan, absolutely nothing. The first diagnostic step is to inspect the outdoor unit's PCB, which is the brains of the operation. So, the technician carefully removes the outdoor PCB from the AC unit. Upon a detailed visual inspection, the technician immediately spots the culprits: a blown fuse and a severely burned MOV, the metal oxide varistor. Now, what causes this? Well, it's usually a high voltage surge, a sudden spike in electricity, which could be due to a power fluctuation from the grid or, unfortunately, a nearby lightning strike during a storm. The MOV, or metal oxide varistor, is a crucial protective component. Its primary job is to safeguard the sensitive circuitry by clamping down on these voltage spikes, diverting the excess energy away from the critical components. However, when the surge is too intense, the MOV sacrifices itself to protect the rest of the board. And when the MOV fails, it often leads to other component failures. Next, the technician initiates the repair process, the desoldering phase. This is a critical and delicate step that demands a steady hand, a high degree of precision, and a lot of patience. First, the technician meticulously removes the blown fuse. Then, they focus on the burnt MOV, carefully desoldering it from the PCB. Before moving forward, the technician ensures the area around the components is completely clean, using either a solder sucker, a desoldering braid, or both, to remove any residual solder and flux. Once the area is prepared, the technician solders in the new components. It's absolutely essential to use replacement components with the exact same specifications as the originals. Check the voltage ratings, current ratings, and other key parameters to ensure the new fuse and MOV are a perfect match. A careful double check of all connections is paramount. Ensure everything is properly seated and soldered, paying close attention to avoiding solder bridges, tiny connections that can short-circuit the board and cause further damage. Now, the crucial moment, the testing phase. Before reinstalling the PCB back into the expensive AC unit, the technician performs a vital safety test on a workbench. For this, they cleverly employ a series bulb setup. The series bulb is a standard light bulb, wired in series with the board being tested. The purpose of this setup is to act as a safety net. The light bulb limits the current flowing to the board, which helps prevent further damage if any short circuits or other problems still exist. If the board has a short circuit, the bulb will glow brightly, indicating a problem. If the board is functioning correctly, the bulb will be dim, or it might not even light up at all. And the results are in. The board powers up successfully, which is a great sign. This strongly indicates a successful repair. The technician can now confidently install the repaired PCB back into the AC unit and conduct comprehensive testing to ensure its full functionality, including the compressor and fan operation. Remember, electronics repair can often seem daunting, but with the right tools, some essential knowledge, and, most importantly, a generous dose of patience, it's often possible to breathe new life into a seemingly dead unit. Always prioritize safety when working with electricity. And if you're not completely comfortable with electrical work, or are not familiar with the safety procedures, it's always best to seek assistance from a qualified and experienced technician. Thanks for tuning in today, and stay tuned for more exciting repair videos right here on the channel.